please open to page 7 in your packet and also have table I ready to go. Table I is going to tell us heats of reaction, or delta H. Its standard pressure, which is 101.3 kPa, and pretty close to standard temperature, or 298 Kelvin. This table tells us how much energy a reaction will absorb or release at those conditions. Delta H, or our change in heat in a reaction, is also referred to as the heat of reaction. The units for delta H are kilojoules, because joules are a measurement of energy. In an exothermic reaction, you're going to have a negative delta H, and this signifies energy is being released. In an endothermic reaction, you're going to have a positive delta H, and this signifies energy is being absorbed. If you look at table H, you can quickly go down and look at some various delta H values. First, we're going to look at which reaction gives off the most heat. In order to find what reaction gives off the most heat, we are looking for a negative value, and we also want to have a very large number. Most of our largest numbers, you're going to notice as you scroll down, are going to be toward the top. So if we compare some of our values up toward the top, we want to find the one that's the largest value that is also negative. We've got some big guys up here. The biggest one of all is right here. And this reaction is the combustion of octane, which is what fuels our vehicles as we drive down the road. So it makes sense that this reaction would give off a lot of energy. We wanted to figure out which reaction is going to still give off, but this time the least amount of energy or heat. We're now going to look up and down on our table and see where we can find a nice small number, but still negative. Smallest negative number I was able to find is right down here, negative 44.51. And this signifies the dissociation of sodium hydroxide. To determine which reaction absorbs the most heat, we're still looking for a large number, only this time we want that number to be positive. So we're going to look for our very largest positive number. After a little looking around, you're going to find that your largest positive number is 227.4, the reaction of carbon and hydrogen to form ethene. And finally, to find out which reaction is going to absorb the least heat, you're going to do the same thing, only you're looking for a very small positive number. And our smallest positive number, right down here, dissociation of sodium chloride. Some typical types of questions that you might be asked based on this reference table are to determine things like how many moles of NH4Cl is dissociated into ions, or if 5 moles of NH4Cl is dissociated into ions, how much heat would be absorbed or released. So the first thing we're going to do is we're going to find this dissociation on table I. When we scroll down and find this dissociation on reference table I, according to how the reaction is written, this is going to absorb 14.78 kilojoules of energy. Now, in front of NH4Cl is a little invisible 1, which means that's talking about if we had 1 mole of ammonium chloride. So each mole of absorbs 14.78 kilojoules. We're going to multiply this by 5. And it's going to give us 73.9 kilojoules. The positive sign right here is showing that this is going to be absorbed. Number 2, in the formation of 1 mole of liquid water, how much heat is absorbed or released? We form water in a couple different reactions. We want to find the one where this is actually going to form liquid water for us. Got this guy right here. This releases 571.6 kilojoules of energy. Now, according to this reaction, to get that much energy being released, we're forming 2 moles of water. So what if we only formed 1? We would have to divide by 2. Which gives us 285.8 kilojoules of energy being released. You should also be able to add an energy term. In the case of aluminum reacting with oxygen to form aluminum oxide, we're going to find this reaction. This reaction's right here. And this reaction has a delta H of negative 3,351. This means energy is being released. This is exothermic. So we're going to show this energy term as a product in this reaction. Even though it's listed as a negative delta H, we don't put negatives in chemical reactions. That negative just says it's a product, so it goes on the right side of the reaction. In the formation of NO2, which is right here, our delta H is positive 66.4. This tells us that 66.4 kilojoules is going to be on the left side because it is a reactant, since this reaction is endothermic. Last thing you should be able to do is roughly sketch a potential energy diagram showing whether or not a reaction is exo or endothermic. In the formation of ethane, C2H6, our delta H value for this is negative 84. So this is telling us this is an exothermic reaction. We don't need to show numbers, just the fact that this is going to end lower than it started. Your homework tonight is page 8 in your packet.